Hello and good morning to everyone. So our today's lead code question is 3713, which is longest balance substring part 1. So in this question we are given a string s which is consisting of lowercase English letters only, and we have to return the length of the longest balanced substring. So what is a balanced substring, right? So balanced substring is a substring in which all distinct characters appears the same number of times, right? Suppose there is a substring having four different characters a b c d, right? And so the frequency of all these four different characters should be same, right? Suppose if a is appearing two times, then b c and d should also appear two times. Then this substring is said to be balanced. So we have to return the length of the longest balanced substring, right? If you'll see this example a b b a c, so what are the different possible substrings? So length 5, if you'll see the full string, so a has the frequency as 2, b has 2, but c has only one frequency, so 5 length is not possible. Then 4 length a b b a, okay, so frequency of a is 2 and frequency of b is 2, so both have same frequency, so we get the answer, that is length is 4. Okay, so let's see the next example. So in next example we have z z, this string z z a b c c y, right? If you'll see the full string, then frequency of z is 2, frequency of a b is 1 1, frequency of c is 2, and frequency of y is 1, right? So full string can't be balanced. Then let's check for length 7 string. This is the length 7 string, it is not balanced. Then check for 6. So what are the 6 length 6 strings is a b c c, it is also not balanced because this frequency. Other is z a b c c y, this is also not balanced. So here if you'll see, we get a b, sorry, z a b c, z z a b c, four different characters and all have frequency 1, so we will be getting answer 4 here. So if you'll see the constraints, the string length is 10 ki power 3. So uh, n square solution will is feasible, right? N square solution is feasible as per the constraints. The other thing is that s consists of lowercase English letters only, that is 26 letters only, right? So let's see the approach for this question. So what we will do is we will form all the possible subarrays, right? We will form all the possible subarrays and then check whether they are balanced or not. Okay, so uh, as let's say the length of the string is n, then all possible subarrays can be formed in big of n square, and that is feasible as per the constraints. And checking each subarray will take big of 26 times. Like how big of 26 times? Because all letters are in lowercase English letters, lowercase. So what we'll do is we'll maintain a vector a b up to z, and then store count of these characters in the subarray. Suppose a appears two times, b appears two times, and so z appears two times. So we'll check whether all the characters whose uh, frequency is greater than 0, whether they have all have equal frequency or not. Suppose here c is 0, so but c has frequency 0, so we won't consider, we consider only those whose frequency is greater than 0, and then check whether their frequency are equal or not. So if you'll see the total time complexity, it will be big of 26 into n square. So yeah, as per the constraints, this solution will be feasible. So let's move to the code part. So if you'll see, what I have done is I have made an answer variable, and then I have iterated from I, and then shifting j for shifting j for making all possible pairs, right? And I have made a vector of characters of size 26 that has initially all frequencies as 0. So a b up to z. So a will be at index 0, b will be at index 1, c will be at index 2, right? This way. Then what I am doing is I am updating characters of s of j minus a. Why minus a? Because suppose whatever character present here, right? Suppose c is present, so the ASCII value of c is 99, and if I'll subtract ASCII value of a, that is 96. Sorry, ASCII value of c is 98, so 98 minus 96, that is 2. So see, this is the index 2 where c is present, right? That's why I'm subtracting minus a. So I am increasing the frequency of that character, right? And then I'll check whether the current substring is balanced or not. For that I have made used a variable p and a count variable. What is count variable? To count the number of unique characters, in the substring. Okay, and p is the like frequency of each character, right? So initially what we do is, if frequency of any character is greater than 0 and p is equal to minus 1, means that is the first character whose frequency is greater than 0. So we will store that frequency in p and increase the count to 1, right? Else if what other case can be there, ki frequency is greater than 0 and characters of k is not equal to p. Suppose right now we have a as 2, c as 3. So this here we will update p by 2. P has become 2. Now we move to this is c, but the frequency of c is not equal to p, means both the frequencies are not equal. In that case we will make count as 0 and break count. Why count as 0? Because this is not a balanced subarray. So what will be answer we are getting? 0 only, right? What third case can be? Key characters frequency is greater than 0 and the frequency is equal to the frequency of the element previously we have stored. In that case we will increase count, and at the end we will take maximum of answer or p into count. Why p into count? So count is giving us the number of unique characters in the substring, and p is giving us the frequency of each character. So frequency into unique character will give us the total length of the substring, right? And at the end we will be returning our answer. So let's see the example walkthrough. So here we are we have taken the string z z a b c y. So I vector, sorry, I index, I pointer, j pointer, this is our vector, and we'll checking is this substring balanced or not, and answer. So initially 0 comma 0. So at 0 comma 0 we have only one substring, that is z, and only one character and with frequency 1, so it's balanced. So we'll update answer from 0 to 1. Then we shifted the j to 1. Now the substring is zz, so one character with frequency 2, it is also balanced. To update the answer to 2, then move to 2. Now we have z z a, but see, two different characters, one with frequency 2, one with frequency 1, so the frequency of both the characters are not same, so it's not balanced, so answer remains same only. Similarly for 3, 4 and 5, the frequencies of all the characters are not same, so these are also not balanced, so the answer remains same only. Next what we do is, now we check for uh, now we check all the substrings at index 0. So we'll do from index 1. So we will be checking from index 1. So 1 1 z is equal to 1. It is balanced, but answer was already 2. Then 1 to 2 a1, both have same frequency, balanced. Answer is already 2. 1 to 3 a b and z balanced. So now we will be updating answer from 2 to 3 and 1 to 4. So our substring is ZABC. ZABC is also balanced. So our answer is updated to 4. Then from 1 to 5. 1 to 5 we have Z A B C Y A B C Y. So all are have same frequency, that is 1. So it is also balanced. So the count is 5. So this way we will be checking all the substrings from each index. Then we do from index to index 3, index 4, index 5 and index 6, and at the end we will be returning our maximum answer. I hope I am able to explain you this solution. So if you get it, please make sure to like, share and subscribe. Thank you.